All right, so let's close out chapter 3. This last lesson right here is on outliers. And I talked earlier in the chapter, like the very first video of chapter 3, I think, about how I took the outlier stuff and pushed it to the end of the chapter. The reason for that is in 2019, the AP test revamped a few things about how the class goes and like how we teach things. One thing of note was how they handled the concept of outliers. So our textbook was written, and I did all my answer keys for homework and stuff before this change took place. So the word outlier has a more like strict meaning than it used to in the AP curriculum. So when you're reading my answer keys or reading your book or stuff like that, the way that they mention outliers is not like how it's been changed or how it's been not like it was wrong before, but it's a little stricter right now. So I'm going to get into that in this video and teach you guys a few new vocab words related to unusual points. Quick lesson, and it should hopefully be like logical and make sense to you guys, but really important stuff. The AP test loves to ask about what adding a point or removing a point would do to a data set. So let's get to it. Unusual points in general is like our catch-all word for like a point that's weird compared to the rest of them. I would argue that this data set as is does not have any unusual points. They all seem kind of more or less of the same mindset. There's nothing crazy going on. And on the side here, there's a few pieces of information. There's a line of best fit, there's R squared, and there's S. And what's going to happen on these next few slides is we add in unusual points in a couple different ways. So let's look at this first picture right here and pay attention to these numbers on the side and see how it changes when we throw this extra point here that's kind of in line with where the line of best fit was anyway. So like I added a point right where my mouse cursor is right now in the pattern of the data. So if you look at the equation itself didn't change. The point was like literally that the adder was on the existing line, so it's not surprising that the line wouldn't change. But R and R squared, on the other hand, are quite a lot higher for this new data sets, okay? R and R squared both got quite a bit higher, and higher is a good thing when it comes to R and R squared. Why did it get higher? You could look back at the formula for R and look back at the formula for R squared and try to look at it algebraically, what a point over here does. Essentially what it does is it pulls the mean up quite a bit. So the point's average distance from the mean is going to increase, and it plays into that formula. But from an easy to understand conceptual perspective, basically what a point over here does, like this dot right here, it makes the linear regression problem think that the pattern lasts a lot longer than it already did. Because in my original data set, my x's are from like 0 to 5, and now you toss in a point with an x of 35 that still follows the same pattern. It kind of makes, think about the formula like a computer or something. It like makes the computer think, oh wow, that same pattern must go all the way to 35. So it raises R because it gives us the belief that the pattern continues past where our data already did. So a point in the pattern of the data like this will increase R. Let's also look at S real fast. You'll notice that S went down a little bit, 2.7 to 2.5. Why did it go down? Well, S is your typical residual size. So you have your residual for all these points right here. And then you're adding in a point with a residual value of basically 0 because it's on the line. So when you put that 0 with all those other points, it makes sense that it would come down a little bit for the average, but it didn't just like go crazy like it did with R. Yet it did still change. Okay, so that is a point, an unusual point within the pattern of your data sets. The next scenario, we're adding a point, we're getting rid of that point that was over here, and we're adding a point down over in this corner that does not follow the data set. So I'm gonna skip between this slide and then 2 up with this slide right here. Okay, first of all, the equation stayed the same when the point was near the line like this, totally changed our equation, even gave it a negative slope compared to where it used to be when I added this point right here. I'll get to R and R squared, but I want to give you a logical explanation for why this is. And I have a really cool visual for this. I took a cat toy string and a stick from my backyard to show you guys what's going on. So this is my like original line of best fit right here. So I've got my line of best fit going on, all right? Most of my points are down over here. So they're hanging out over here. If I add a point over in this part of the picture here, bottom right, which is what I'm trying to do, that point is kind of going to pull the line towards it because the line doesn't want a residual this big to show up because that's just going to mess things up. So the line kind of shifts towards that point, pulls the point in that direction, or the point pulls the line in that direction. So that way, that residual isn't as giant as it used to be. So I went from a nice positive slope line, and picture this point grabbing the line, tilting the slope, and the y-intercept also went from here to here. So it made a big difference in your slope and in your y-intercept and in the equation of the line just altogether. Lots of change going on right there. If we look at our equation, I already said the equation changed. Let's look at r and r squared. 0.4, 0.17. Gets a lot worse. Gets worse anyway. 0.3, 0.18. So the 0.4 to 0.3 was a change. It already wasn't a great correlation, but it definitely hurt it. And it made it negative because it's going downwards. So r and r squared were definitely affected by that new points. S was also affected a bit. It got a little bit higher because when you mess with the line like there, now all the residuals on that little left side are a little bit bigger than they used to be. Okay, so that definitely made a difference in several of the things. The biggest change was definitely to the slope right there. And then we have another unusual point. This time though, the picture is on the same scale, so like it looks a little deceptive like there. But basically, this point right here has the same sort of x's as all those other points. It's just way outside the pattern right here. So picture again with my nice little visual aid right here. Before, what I did is I had my points here. I put a point here, and that's going to grab the line and tilt it towards you. Now picture, though, I've got all these points in the middle right here, and I add a point like in the middle up top. What's going to happen then if you pick a point in the top, like around all the other points, instead of tilting the line, what's going to happen is that point is just going to pull the whole line upward. So instead of being like here, the point which is where my hand is going to shift my line vertically or horizontally, like vertically up or down like this. So if you have a point in the middle of all your other points, like this guy right here, picture like that guy was attached to a string right here. It's going to yank the whole line upwards a little bit. Instead of being like through the middle of the points here, it shifted the whole line up. The slope might have changed a little bit, but the biggest difference there is in the y-intercept and the vertical placement of the line. R and r squared are definitely changed. These are way lower than they used to be. So this point had a bigger effect on hurting r than the point over here did. And look at s. There's nothing the line can do to help this point right here. So your s just got tanked. It went from like 2 to 10. Okay? So when you're looking at an unusual point, all three of the last things I showed you, so that being here, and then here, here. All of those are unusual in the sense that they're not like the other points. But we have different vocab concepts for these, and they do different things to our equation. Let me go ahead and give you those three terms that you guys have to be familiar with. The first one is called an influential point. And an influential point influences our existing stuff in some way. So an influential point, adding or removing it, would make a substantial difference in either or in any of your intercepts, your slope, your r, your s, your r squared. If any of our friends from this chapter are significantly different because of that point, either being added or being deleted, that point is influential. Okay? So I'm going to leave that up for just a second here, even though it'll still be on my screen. But if you look back at my original picture, none of these dots here, I don't think, are particularly influential. If I deleted one of them, I might get like a tiny bit of movement in my line, but it's basically going to be the same line. So these points right here are not influential. This guy is influential because it really raised our r. It changed r and it changed r squared. Didn't change the equation, but it changed something in our little menu right here, so it's influential. This point changed our slope quite a bit, influential. This guy, this guy changed our y-intercepts. So it's also influential. So if it changes something, it's influential. Our next vocab concept is the concept of a high leverage point. And a high leverage point is going to be like the, I'll be right back. All right, a high leverage point has an X value that is different. So an X value far away from the other data points. And a high leverage point influences the slope of your least squares regression line. So that was my middle example. When my line went like this, I put a point over here. All my other points are there. It changed the slope of my line. Doesn't have to be this drastic from here to here, but if it's on the edges of the graph, like if it was up here, it might tilt the line this way. Points on the edge of the graph have an influence over the tilts of your line. So that's what's going on there, and that was the middle example on our 3 pictures. Finally, the concept of an outlier. Outliers are defined under the new curriculum here. It's not just any weird points. I can't see if outliers on there. Yeah, it is. All right, outliers aren't just any weird points. They're going to be points with significantly higher residuals than other points. Okay, so it's a point with a much bigger residual than other points. And let me show you in the pictures what that looks like, and that'll be our chapter. So, in my 3 unusual point pictures, my first one is this guy right here. This point is not considered an outlier. It is a high leverage point because it's far away, even though it didn't change the slope. Points far away have the ability to change the slope. So this guy, it would be considered high leverage. It is not an outlier because the residual is basically 0. It's still in the pattern of the points. It's just beyond. So not an outlier. My next slide had an example right here. And then when you look at this example, this point is an outlier. And the reason it's harder to see, because if you look at this, you're like, oh, it doesn't have a big residual. Look at it when it was like before. So if I go back to the original data sets, adding in a point over here would have a quite large residual. So that is an outlier. It also doesn't follow the pattern of the points. So I'm going to add that to my definition in just a second, but it's a point with a large residual that doesn't follow the pattern. And my last example here, this guy has a really big residual as well, and it does not follow the pattern of the points. So this would also be an outlier. So the first guy is not an outlier because it was in the pattern and small residual. I guess it was case 3 and case 4, the last 2 pictures there, both are considered outliers. So add on to your definition. I can't remember exactly what I had you write already, but it's for outlier. It's outside the pattern of the other points of the other data. So be careful when you use that word outlier. It's like kind of instinctive to be like, oh, weird point, outlier. But the way you use it in this chapter has to be a little more measured using this criteria here.